Assalamualaikum, I'm Fudila Tasnim.
Hi, my name is Naima Amira.
Hello, my name is Marsha Akila.
Hi, my name is Ahmad Danish.
So, what is a moment? A moment is caused when a force acts on an object at a distance from its pivot point. The further the distance or the bigger the force, the larger the moment.
Have you ever wondered how do force, distance from pivot, and direction of force affect moment? First, force. The greater the force, the greater the moment, because moment is directly proportional to the force.
Here, I place one book on the table. The force is small, so the moment produced is also small. Now, I increase it to 3 books at the same position. The force becomes greater and the moment increases. Second, distance from pivot. The further the distance from pivot, the greater the moment. I put the books on the table close to the pivot. The distance is small, so the moment produced is also small. Then, I move the books further away from the pivot. As the distance increases, the moment becomes larger.
Third, direction of force. The moment is strongest when the force acts perpendicular 90 degrees to the object.
Now, let's have a look at the equation.
So, this diagram shows the forces and moments acting on a folding table. The main idea here is to understand how the table stays in equilibrium. In the diagram, the pivot is shown at the hinge of the folding leg. This is the point where rotation could happen, so it's the reference point for calculating moments. There are several forces acting on the table. Weight of table acting downwards, weight of book also acting downwards, the normal reaction forces at the contact points, and each of these normal forces has x and y components. For rotational equilibrium, summation of moment is equals to 0. That means the total anticlockwise moments is equal to the total clockwise moments. So, substituting the forces given, Rn2y equals to Rwt plus Rwb, or equivalently, Rn sin theta equals to Rwt plus Rwb. Next, the sum of forces in both the x and y axis must be 0. So, horizontally, n1x plus negative n2x equals to 0, which simplifies to n1 sin theta equal to n2 sin theta. For the vertical direction, n1y plus n2y plus negative wt plus negative wb equals to 0, and in terms of components, n1 cos theta plus n2 cos theta equals to wt plus wb.
In Surah Ar-Rahman, verse 7 to 9, Allah says, وَالسَّمَاءَ رَفَعَهَا وَوَضَعَ الْمِيزَانَ أَلَّا تَطْغَوْا فِي الْمِيزَانِ وَأَقِيمُوا الْوَزْنَ بِالْقِسْطِ وَلَا تُخْسِرُوا الْمِيزَانَ. As for the sky, He raised it high and set the balance of justice so that you do not default the scales. Weigh with justice and do not give short measure. This verse reminds us that Allah creates the universe in perfect balance in all aspects. In physics, the concept of moments is also about balance and equilibrium. When the clockwise and anti-clockwise moments that equal an object, we can say it's balanced and stable. Similarly, Allah designed the world with precise balance. If one force exceeds another, instability will occur. In this shows that the laws of physics, like the law of moments, reflect Allah's wisdom and justice in maintaining order and equilibrium throughout His creation. So now, we will compare these two foldable tables. As you can see, one with slanted leg and another with vertical legs. Physically, the slanted leg gives better stability because the base area is wider. To prove it, we analyze both using equilibrium equation. For the slanted table, the reaction force on the leg have both horizontal and vertical component, while the vertical table only satisfies y component. In conclusion, slanted leg table is more stable and able to hold less heavy books, while the vertical leg table is vice versa.